Right now, there's a tiny spacecraft hurtling through the darkness at 38,000 miles per hour, and it won't stop for 1 billion years. In 2027, Voyager 1 will celebrate 50 years in space. By then, it'll be 176 astronomical units from the Sun. That's 24 light hours away. To put that in perspective, light from the Sun takes 8 minutes to reach Earth. Voyager 1 is so far that sunlight takes an entire day to get there. But here's the crazy part. Even at 38,000 miles per hour, it would take 300 years just to reach the inner edge of the Oort cloud, and 40,000 years before it gets anywhere near another star. So the question isn't just how far will it go, it's what will happen to it along the way. See, back in the 1970s, NASA realized something incredible. The outer planets were lining up in a way that only happens once every 176 years. This alignment meant a spacecraft could use gravity assists to hop from planet to planet, like a cosmic slingshot. They called it the Grand Tour. Voyager 1 launched on September 5, 1977, with a simple mission: study Jupiter and Saturn up close. But what it ended up doing, that changed everything. In March 1979, it reached Jupiter. The images it sent back were mind-blowing. Intricate cloud patterns, storms the size of Earth, and that massive swirling beast we call the Great Red Spot. But the real shock came from Jupiter's moons. Io, one of Jupiter's moons, was erupting with volcanoes, the most volcanically active body we'd ever seen. Lava flows, plumes shooting hundreds of miles into space. Nobody expected that. Then there was Europa, smooth, icy, and beneath that ice, scientists started to suspect there might be an ocean, a place where life could exist. A year later, in November 1980, Voyager 1 reached Saturn. The rings, those beautiful, iconic rings, turned out to be way more complex than anyone thought. Thousands of ringlets, gaps, structures that shouldn't exist according to the physics we knew. And then there was the F ring, which Voyager 1 discovered for the first time. But the biggest discovery? Titan. Saturn's largest moon had this thick orange atmosphere, dense, hazy, filled with nitrogen and hydrocarbons. Organic chemistry happening on a massive scale. It was like looking at a frozen version of early Earth. After Saturn, Voyager 1's primary mission was done. But NASA realized this spacecraft still worked. It had fuel, it had power, so why stop? In 1990, they started what's called the Voyager Interstellar Mission. The goal? Push beyond the solar system and see what's out there. Before it left the inner solar system behind, NASA commanded Voyager 1 to turn around and take one last picture of home. That's when we got the pale blue dot, Earth, a tiny speck suspended in a sunbeam, barely visible. Carl Sagan said it best: everyone you love, everyone you know, everyone who ever existed lived on that tiny pixel. 8 years later, in 1998, Voyager 1 officially became the farthest human-made object from the Sun, surpassing Pioneer 10 at about 69.4 astronomical units. That's 6.4 billion miles. But the big milestone came on August 25, 2012. After 35 years of flying, Voyager 1 crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. It became the first human-made object to leave the solar system. And when it crossed that threshold, it started sending back data that blew scientists' minds. Cosmic rays, way more intense than inside the heliosphere. Magnetic fields twisted in ways we didn't predict. The density of the interstellar medium, the stuff between stars, was different than expected. For the first time, we had direct measurements of what space between the stars actually looks like. Now here's the engineering marvel.
Voyager 1 is still talking to us, right now, from over 15 billion miles away. It uses a high-gain antenna, just 3.7 meters wide, to beam radio signals back to Earth. Those signals travel at the speed of light, but they still take over 20 hours to reach us. Think about that. You send a command to Voyager 1, and you won't know if it worked for almost 2 days. NASA communicates with it using the Deep Space Network, 3 massive radio antenna stations in California, Spain, and Australia, spaced 120 degrees apart around the globe. As Earth rotates, there's always one station with a line of sight to Voyager 1. But here's the problem. Voyager 1 is dying. Its power comes from radioisotope thermoelectric generators, or RTGs. Basically, they convert heat from decaying plutonium-238 into electricity. But plutonium-238 has a half-life of 87.7 years, and the RTGs lose about 4 watts of power every year. By 2025, next year, Voyager 1 won't have enough power to run any of its scientific instruments. Engineers have been shutting them down one by one to keep the spacecraft alive as long as possible. Eventually, probably within the next few years, it'll go silent. But even when it stops talking to us, it won't stop moving.
So what happens next? Voyager 1 is currently heading toward the constellation of Fucus, but over the next billion years, it could pass through or near Hercules, Lyra, Cygnus, Draco, and Camelopardalis. That's thousands, maybe tens of thousands of stars. But here's the thing, predicting its exact path is almost impossible. Over millions of years, tiny gravitational tugs will add up. Passing stars, molecular clouds, even the tidal forces of the Milky Way itself will nudge Voyager 1 off course. These changes are minuscule in the short term, but over eons, they become massive deviations. And the stars themselves? They're moving too. The constellations we see today won't exist in a billion years. Stars will die, new ones will form, and the galaxy will look completely different. Voyager 1 will pass through regions of varying density, sparse outer halo, denser zones near the galactic core, each with its own gravitational quirks. It'll drift through dust clouds, gas, plasma. Some of these particles will hit it, slowly wearing it down. Micrometeoroid impacts, cosmic radiation, thermal cycling as it moves through different temperature zones in space. Over hundreds of millions of years, these forces will take their toll. But here's what's wild. Voyager 1's structure could remain recognizable for hundreds of millions, even a few billion years, assuming it doesn't slam into something big. By that time, it will have traveled around a quintillion miles. That sounds insane, right? But that's only 1.7% of the Milky Way's diameter. Space is unimaginably vast. Still, during that journey, Voyager 1 will pass through countless stars. It'll drift through stellar nurseries where new stars are being born. It'll glide past dying stars, red giants, white dwarfs, maybe even a supernova remnant. And it'll do all of this in complete silence. No signals, no data, no communication, just drifting. But it's carrying something. Attached to Voyager 1 is the Golden Record, a 12-inch gold-plated copper disc containing sounds and images from Earth. It's humanity's message in a bottle, cast into the cosmic ocean. The record has greetings in 55 languages, music from Bach, Chuck Berry, Javanese gamelan, tribal chants, natural sounds, thunder, wind, whales singing, a baby crying, and 116 images showing what life on Earth looks like. There are diagrams explaining where we are, what we look like, how our biology works, instructions on how to play the record. It's a snapshot of humanity in 1977. The chances of anyone finding it? Astronomically small. Literally. But that's not really the point. The golden record isn't just for aliens, it's for us. It's a reminder that we're capable of looking beyond ourselves, beyond our planet, beyond our own lifetimes. Voyager 1 will outlast us. It'll outlast our civilizations, maybe even our species. Long after Earth is gone, long after the sun has died, Voyager 1 will still be out there, drifting between the stars. In about 40,000 years, it'll pass within 1.6 light-years of a star called Gliese 445. Not close enough to be captured by its gravity, but close enough that if there's anyone there, they might see it. And if they do, if some distant intelligence finds Voyager 1 billions of years from now, they'll discover that once, on a small blue planet orbiting an average star, there were beings who looked up at the night sky and wondered, what's out there? And then we built something to find out. Voyager 1 is more than a spacecraft. It's a testament to human curiosity. The idea that we can launch something into the void, not knowing if it'll ever be found, just because we had to try. Right now, it's out there, silent, alone, moving through the darkness at 38,000 miles per hour. And it won't stop. Not in our lifetimes, not in 1,000 lifetimes. Voyager 1 will travel farther than any human will ever go. It'll see things no one will ever witness. And even when the last star in the universe burns out, even when the cosmos goes dark, Voyager 1 will still be moving, a tiny monument to a species that dared to reach for the stars. And maybe, just maybe, someone out there will find it and know we were here.